In this video, I'm going to talk about the derivation of indirect utility function. Assuming that we are given this direct utility function, how we can derive an indirect utility function equivalent to this direct utility function. This utility function called direct because the value of utility here is a direct function of the amount of good 1 and good 2. So to derive the indirect utility function, at the first step we need to find the optimal value of x1 and x2. To do so, we max this utility function subject to budget constraint. So we set up our Lagrangian here and then take the first order conditions with respect to x1, derivative of Lagrangian with respect to x1 equal to 0. We get equation number 1, and derivative of Lagrangian with respect to x2 equal to 0, we get equation number 2, and the budget constraint must hold for this first order conditions. By dividing equation number 1 over number 2, we get this term here. We can more simplify this term by applying a very simple math rule. We know that x to the power of alpha is equal to 1 over x to the power of minus alpha. So by applying this simple math rule, we can simplify this term and get equation number 4. Equation number 4 says the value of x2 is a function of value of x1. If we substitute equation number 4 to equation number 3, we can get the demand of the demand for good 1. So substituting equation number 4 to equation number 3, we can get p1 x1 plus p2. Here is the value of x2. We can simplify more here. So here p2 with this p2 will cancel out, and then by simplifying more, taking out p1 x1, and finally here we get the value of x1. So the value of x1 as a function of p1 and m is equal to alpha m divided by p1. We can substitute equation number 5 into equation number 4 here. So in equation number 4, x2 is equal to p1 over p2, 1 minus alpha over alpha times x1 here. And then we get equation number 6, which is the optimal value for x2. These two number 4 and number 5, are called the Marshallian demand. Marshallian demand for good 1 and good 2. So if we substitute the Marshallian demand to the direct utility function, so here is my direct utility function. If I substitute Marshallian demand for good 1 and Marshallian demand for good 2 here, see here the good 1 here and good 2 here, we get we can get the indirect utility function. So here is the indirect utility function. We show the indirect utility function with the notation v as a function of p1, p2, and m. So it's called indirect utility function because the value of utility here is a function of p1 as a function of p2 and as a function of m. There's no direct x1 and x2 involved here, so that's why it's called indirect utility function. In next video, I'm going to talk about how we can derive the Hicksian demand and expenditure function.